Bonjour, mesdames et messieurs. Buenos días, damas y caballeros. Good morning, ladies and gentlemen, and welcome. My name is Sung-Hoon Kim. I'd like to welcome you to the International Civil Aviation Organization's 40th Assembly SkyTalks. Over the next 2 weeks, we have 68 presentations from aviation industry professionals for you. Should you have missed any of those presentations, I welcome you to go to the ICAO channel on YouTube to find out more information. Now, during this upcoming presentation, which is day 3, session number 4, our speaker has invited you to participate in a town hall type of meeting. So I'll be holding the mic and passing it around for you for your convenience so that you can ask questions during the presentation. The title of the presentation is Increasing Global Capacity and Safety by speaker Ori Shloosh, CEO and Chief System Architect at IATAS. Without further ado, please welcome Ori Shloosh.
Thank you. Good morning, ladies and gentlemen. It's great to have a nice turnout. So, what I'd like to talk about are certain technologies and services that are available today to all states under the No Country Left Behind initiative. And what we'll be doing is we're going through certain sections, and each section I'd like to have some interactive few minutes with you, and hopefully you can raise some questions or issues or concerns that you might have, because you're all regulators, right? So, if we talk about pilot situational awareness today, at airports, there's an airport moving map, which is becoming mandatory by 21. The issue with that is that the pilot only sees their own aircraft and where they are. That is not situational awareness. You really can't see what's going on. Now, the other thing is, if you have, if you're at an airport that is not in your language, not operating in your language, you got to have English proficiency. And as we all know it, we call it English improficiency. So what would pilot situational awareness look like? As you can see on the slide, on the right-hand side, the aircraft itself, which is the own ship, your own aircraft as a pilot, you get to see all other traffic around you, including aircrafts, vehicles, as well as all the conditions, the runway conditions, the braking action, and any of the operational parameters that you require for each of the flight phases. So if you're lining up on the runway, you would see a different menu, and again, everything in your own language. This is for a takeoff. Can I have a replay, please? Thank you. So as you can see on the top right-hand side, the pilot can see the winds. He doesn't need to get that from ATC. He can see the departure frequency. There's actual timers that allow the pilot to know when is the next operation that he should expect to receive from ATC, especially for getting onto the runway or crossing a runway or the takeoff roll. Now, part of the benefits that the pilot has here is, first of all, is pushback time. As you know, in most places in the world, what happens is, first thing that we do is we push back as pilots, and then we're number 15 for the takeoff. So we waste fuel and CO2 emissions. So what we do here actually is we provide the pilots with a countdown timer telling them, no, wait 4 minutes, you'll be number 5. So use less fuel, less carbon emissions. Now, once the aircraft push back, we also provide the pilot with what's called optimal taxiing speed. So between two junctions, they have a certain speed, and if they maintain that, they wouldn't need to stop and restart most of the time. Again, this is for fuel savings and CO2 emissions. So I know there's some people here in the crowd that's important for them. In addition, all the information that is required for clearance delivery, which we'll talk about that shortly, is given way ahead of time. Again, winds, crosswinds during the landing, optimal taxiing routes. When an aircraft is coming in for landing, it's being handed off from approach to the tower. This map comes up, and it will show for each one of the exits from the runway how long it would take for the aircraft to get to the gate. So the pilot can request a certain route. Any questions about this particular item? This is for the pilots, and I was showing this particular one.
It's me.
Please.
Hello. Me, I have one question. The system behind that, are you able to explain a little bit the system? It means the data communication, the collect, all the collect GPS and everything. How work the system behind that? So
the infrastructure is on a per airport basis, and it connects to the anemometers, which is how it shows the wake separation and things of that nature. And it connects to the PSR, SSR, to the radars. If the airport has additional services for surveillance, it mixes all that information in, and then it's relayed over to the cockpit.
Okay, so for the intrusion of the maybe other vehicle, you have something also to do that?
Right. Again, this would be based on the surveillance that's available at the airport itself. So airports without WAM or without proper surveillance wouldn't be able to receive that. So it's on a per airport basis. Also, the communication, it's important to understand that some of you might know the term called CPDLC, the controller pilot data link communication, which is only at certain big airports around the world, mostly in the US. It's very restrictive. So this system is actually agnostic to the communication. So it would work on cellular, it would work on Wi-Fi, and it has its own encryption. So hopefully that answers your question.
Thank you.
Okay, any more questions regarding the moving map?
I think the last one on the best possible route to save fuel.
Yes.
At what time does the pilot get this? Because he would have already filed in his flight plan.
Okay, you're talking about the route that's airborne, right? I was talking about the route for taxiing.
Okay.
I'll be touching on the actual routing in a later phase for the airspace. That's a really big part of this presentation.
Okay.
Okay, so for the airport itself, it's in real time. It does allow for progressive taxiing, and you get that prior to pushback as well.
Oh, I see. Okay. But does the pilot have a choice on the best possible route to save fuel?
Sorry, if he has?
The pilot, does he have a choice to choose that the best possible route to save fuel?
Yes. So the true answer is it depends on ATC, and if the ground system that is being used by ATC is the same system as this.
Okay.
If it is, it will automatically provide the pilot with the best choices, and if he clicks it, that will be his route. So
okay.
the answer is yes.
Okay,
But
thanks.
pilot always has a choice to say no to ATC. So,
Okay, thanks.
right.
Thank you very much. Is this service provided by the ANSP or the airport authority? And secondly, is it related to the ASBU Block 0, air traffic situation awareness for air flight crew?
Great question. So I'll break it up into two. So the operational side, who operates it, it's generally the airport. The users are the ANSP who run the control tower, but it does not require the tower 100%. So if you just like to have situational awareness for the pilots without the added routing, for example, you just want them to see the traffic around you, you don't need ATC. So you can run that as an airport or the airport authority, whoever operates that. To answer you as part of ASBU, it is aligned with ASBU 0, okay? And it conforms to DOC 9830, all the SMGCS. By the way, this is part of an SMGCS level 4, so fully automated. We can get into that, but I'm not sure we have the time today on that. So I'd like to move forward. One more question here, please. Go ahead.
Yeah, morning.
Morning.
would it really be worth it giving the pilot the option for deciding on what will be his optimum route? Or would that not be more appropriate for the air traffic controller to decide?
So this is a two-way system. This is a super question. So there's two sides to this. The first side is the ATC actually provides what routes he is making available to the pilots to choose from, and the pilots choose from that. So the system knows which routes or partial routes are available, and then it provides that to the pilot. Again, this is an ATC pilot communication that could be overridden by either party, generally by ATC. But if ATC clears that route pre the service, then the pilot can choose that because he already he gave the okay for that. And if he didn't, he wouldn't see that as an option. ATC could always override because it's under his control. Okay. Let's move forward. Time is moving fast. All right, I'd like to talk to you about global incursion epidemic. So as you know, incursions are happening at all the busy airports around the world. And it's not something that seems to be going away. The human factor is a big thing. When we look at it, there's really no physical mean to stop an incursion. So the problem today is that the EFB doesn't show any of the traffic. The stop bar alerts are too late, meaning that when an aircraft passes the stop bar, the air traffic controller sees the alert, and then he tries to alert the aircraft, and then he mumbles because of the pressure. He doesn't say the call sign. We've seen this again and again. The latest one, the one that's showing on here is from Shanghai about a year and a half ago. They missed each other by 15 meters. Most of you probably know about this one. And the latest one was just about a week ago in India. So these are things, most of it we don't hear every day, but it does happen every day. So what can we do about that? What about situational awareness? The pilot doesn't really know what's going on unless ATC tells him because of the distances. And what happens when you have poor weather? So we have to start thinking about changing the mindset from ensuring safety to marshaling safety. So how can we do that? So the first thing we got to do is notify the pilots. So in real time, what the system does is it takes a look at the deceleration rate of the aircraft that's approaching the stop bar. So if we have an aircraft taking off, another aircraft approaching the intersection, the crossing, and it's not stopping in time, we need to alert all pilots that are involved in that incursion in the making. Okay, so that is something that we need to do right now, which we're not doing as an industry. And obviously, second thing we got to do is notify ATC. Now, the second phase of this, and this is where the industry needs to get involved, today we're already sending a signal to the aircraft. If that particular aircraft is not going to stop in time, we send a signal to the aircraft of the likelihood of a collision to apply the brakes. And that is for the aircraft manufacturer to mitigate how to work with that. So one of the things that we're doing, if it's low imminency, then perhaps the manufacturer would place an alarm in the cockpit. That is up to it's like a TCAS, but on the ground. But we just send the signal. But today the manufacturers don't know what's going on, and not in time. Okay, any questions about the incursion? Good. It's a new concept, right? It's a little different. Like I said, it's a mindset switch from insuring to marshaling. Okay, this is the main topic that I'd like to talk to you about. Oh, sorry, there was a question in the back, sorry.
Yeah, I just wanted to know if they track all vehicles or just planes on the runway.
Right, so as said before, it depends on the surveillance available at the airport. So if there's surveillance available, including the vehicles, it would include that as well. And it's an interesting point that you mentioned. I just said the intersection between the runway and other taxiways, but this is true for any other place within the airport, within the airside, also including geofencing for particular areas which might be sensitive, whether it's military or delegations or whatever. You can apply that same mindset anywhere else in the airside. So thanks for bringing that up. Did I miss any questions? Okay, good. So global ATFM synchronization. Today, if we take a look at how states are doing air traffic flow management, most states are on their own. Most don't even have air traffic management capabilities. And aside from Eurocontrol and the states which are synchronized, and some work being done in South Asia, which they're having their own system, which is not really working, there is really no global synchronization. And what do I mean by global synchronization? So today, departure and in-flight clearances are not globally synchronized. So if we fly here from Montreal to somewhere else, only NAV Canada would provide the clearance, but it doesn't take into account, if we fly to Istanbul, the Turkish ANSP is not part of that clearance, just a Canadian. And then they would relay that information through Eurocontrol. So what it looks like today, as you can see, the ABCD and so on are the states, the ANSPs that are within the route of a particular flight. The red line represents the deviation from the route that was supposed to be based on the ANSP's requirements at the same time, whether it's for weather or military exercises or whatever it might be. And the yellow line represents the deviation in altitude. So although it should be nice to have the same altitude unless there's weather issues, what we see is because of operational requirements for the ANSPs is that each ANSP is working in silos and they're managing their traffic their own way. So there's no synchronization between everybody. Now, needless to say, as you can see this, there's no fuel savings here. And the CO2 emissions might be a little more than they should be. So maybe there is a way that we could provide a more effective way for everybody to be on the same page. The other point is that pilots today, when they request a flight plan, they do that 3 to 4 hours before the flight. They drink their coffee and they look at the weather maps, they file it, and then only once they get into the cockpit, they receive the clearance 3 or 4 hours after. So it's sort of an I wish flight plan. It's a plan, but it's not approved. Now, this requires air traffic controllers, usually at the airports, to provide the clearances. There's a lot of read back and hear back issues. And there was a decision made in the ATM RPP not too long ago to provide clearances with non-CPDLC means. So other technologies could be introduced now to provide clearance delivery. So let's take a quick example of a flight from Paris to Bogota. Eurocontrol would provide the pre-departure clearance based on its member states and everything that they plan. Now, all of the non-Eurocontrol states are not really part of that pre-departure clearance, as we talked about before. Each state provides the clearance, and then the other states are not really part of that. Now, the handoff times between the states, even while it was planned in Eurocontrol, are off. Why? Because each one of those ANSPs is working in silos. So one thing is being, so say a flight is handed off for France to NATS, for example. The entry time is not really known. Okay, it's estimated. So what if any state, any ANSP, could maximize the flow prediction by hours, by 4 and 6 hours? So you'd have more accurate information. Optimize the routes to commit to a pre-departure clearance, which I'll talk about in a second. on a global scale, and then request delays and possibly halts in other regions or states because you're having weather issues. So we'll go back to this slide here. And what we actually do is the system will go when, prior to the flight, 4 to 6 hours prior to the flight, it will take a look at the weather throughout the possible routes for that flight. It will request for from each one of those states to commit to a set of routes for that state, for that ANSP. And then the system creates a list of routes for the pilot to choose from. So he doesn't need to take a look at weather maps because that's been done for him, and it's already cleared for him. So as you can see, this is on the user interface side for the pilot. He can go and move between different plans. He clicks on the one that he wants. That's the clearance. That's the flight plan, 4 to 6 hours prior to the flight. Unless, there's like a blown tire or something like that, which delays everything. He jumps into the cockpit, pushback. No need for clearance delivery from ATC. So you're not waiting at the gate another 5-10 minutes. And once the aircraft is airborne, the pilot receives a dispatch service with all alternate airports available depending on the aircraft performance, and ATC messages, ATFM messages, any weather changes. As you can see at the bottom, it tells them that there might be a better clearance available. And the pilot doesn't need to talk to the controllers. It doesn't really need to request a new flight plan. Okay. Any questions? At the front? In the back, sorry.
Good day. I think with reference to the software, I think you should include also the airline personnel as well as the AIS office, because most of the time if there's a deviation in speed or altitude, for weather, it's based on, it's like a contingency plan. Pilots may have generic routes from their airlines, and every single other pilot may ask for a different route to be more accommodating for them. So it shouldn't just be between the ATC and the pilot, because the ATC is basically accommodating the pilot. And the pilots fly the best route they could in the interest of safety and expedition. So when this is done, it should start from the filing of the flight plan. So they could actually find an optimized route for each day so that the pilots wouldn't have to make any requests and ATC wouldn't have to change their plans. So that's what basically happens on a daily basis.
Thank you. So there are, I didn't have enough time for all the slides, but there are means for pilots to have their special routes and having it cleared by ATC. So it still goes under the old way of doing things, but it's still through the same user interface. So they can draw their own route if they wish with the weather. I just didn't have time to show all this. So it does have that. Thank you very much. I think there was at the front a question.
You talk about the solo, the ANSB. All you manage all the area at each state, and all the people is all the service provider. How you try to make the deal to make not solo, you understand? It's not solo, it must be a team, all the team around the route. Now it's solo. How you try to convince people to work together? How you do that?
Super question. So the main issue for ANSPs are predictability and operational efficiency. So as an ANSP, if you're able to see what's coming into your airspace 4, 6, 12, or 18 hours prior to the flight, it's a lot more predictable when you're already committed to certain routes. So it makes your operation a lot more efficient, and it's an easy added value for ANSPs to understand and move forward. So there are several states that are already signed up for that, and just before I bring somebody special here on the stage, any country can implement any of the service today. And at this point, I'd like to bring Gilbert from ICAO to join me on stage, if you like. Can we mic Gilbert?
36,
No, you have 5 minutes, if you like. So.
Okay, I met yesterday Ori on the kiosk on a booth, and I'm very impressed with everything. So I read all the night what he tried to do. So I think he worked since 10 or 8 years with everybody, with Next Gen, Cesar, and everything to try to make real time. Everybody tried to make swim and all the things, but the question, the most important, is where, if you succeed to collect the data, it will be very good for all the country, and it will be in the strategic objective about the no country left behind. So I agree with what he's tried to do, and I hope the country, because he explained me that you pay by fly, so I understand exactly perfectly everything what he's tried to do. But I think for the future, if we have more people like him, it will be a great event for the aviation, for everything. Because when we create map, you know where is the traffic, and now he tried to.
Is this fresh?
Yes, it's
you
fresh.
just printed this?
I told that here. Okay, it's okay.
That's a big one.
So you want to start with the African here. You want to start with Kenya and maybe other country, because here it's. If we start to make something provision like clearance here and everything here, so we're able to make more to help the traffic here. So when you are there, here it's 40% and here. So we try to start that to find country that will want to sign to help that people in that region. So I don't know more about that because he worked a lot more on that concept. But I just tell you, that is what he try. If he succeed, it's all the organization and many, many things arrive. But we must be patient and we must work hard. So I give you that, and I fold that, and I continue to talk because it's more complex.
Thank you very much. Final questions or anything? Yeah, please.
Thank you, Ori, for your presentation. My question is, why would you want to start with Africa, and where there's clearly less traffic, huge population, but less traffic?
Thank you. So when you try something out, if we were to try this in Eurocontrol, for example, the sheer volume might provide us with challenges in the beginning that we'd rather do on a smaller scale. That's one. Two is, if we concentrate on Eurocontrol or the States, we would have a non-global mindset. And it's important to understand that to have a global view, you need to have participants that are connected to the world, but you're not concentrating on them. And Africa is a great example. So if we take a look at Kenya, a lot of traffic that goes to the UAE and South Africa goes through that corridor, and it automatically goes to Eurocontrol. Now, we've been talking to Eurocontrol. So there's 4 states that are already signed up, some in Asia and in Africa. And it doesn't cost anything to sign up. You're welcome to join, and just email us. Any more questions? I thank you very much.